Math 60. In this video we're going to talk about section 1.8 where we discuss exponents and order of operations. Let's first define exactly what we mean by an exponent. So remember that if b is a real number and n is a natural number, remember natural numbers are the counting numbers and not including 0, right? Natural numbers being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on and on and on. Then we define the following. B, with this little exponent notation up here, we say b to the n, or b to the nth power. This is defined as the following. It's repeated multiplication of this base number b, right here. So we just do b times b times b times b n times. Okay, so we call b the base and we call n the exponent. We read this expression as the nth power of b, or b to the nth. We can see examples with exponents in them when we consider algebraic expressions. For example, we have 3x squared plus 7x squared. When we have the same power on the variable in a term or in two terms like this, we're able to combine like terms. So here they have the same variable factor. They're both x squareds, and they're both a certain number of x squareds. This is 3x squareds and this is 7x squareds. We're able to combine the two things because the x squares are the same variable factor. They are alike. So here we have a total of 10x squareds. In this alternative example here, we have 5x cubed, or 5x to the third, plus 4x squared, or plus 4x to the second. This cannot be simplified any further because here we do not have like terms. X to the third is not the same variable factor as x squared. They are different. So we're not able to add these two things together because they are not like terms. Here, let's see an example where we actually do simplify an algebraic expression that contains exponents. So we're going to combine under addition only the terms that are like. The variable parts of the terms have to be the same for them to be considered like terms, just like we did a second ago. After we have combined all of the like terms, all of the variable parts that have the same power on them, the same exponent, we can't go any further after that. So in our example here, we have 3x to the fourth plus 2x squared plus 5x to the fourth minus x squared. So first what we do is we group together the variable factors that are similar, that are like. So we're grouping together the 3x to the fourth and the 5x to the fourth because they are like terms. They are both containing x to the fourths. Those are grouped together here in the front. Then what we're doing is saying, okay, now in this second grouping, group together the things that are x squared. So I have a plus 2x squared and a minus x squared, and those two things are being grouped together. The x to the fourth terms here are like terms. They can be combined. 3x to the fourth and 5x to the fourth is 8x to the fourth, plus, now we combine these like terms here. The variable factor is x squared, so 2x squared minus x squared. Remember that there's an invisible 1 being written right here, yes? When there's nothing written in front, the coefficient is assumed to be a 1. So we're subtracting a single, or 1x squared, which leaves me with 2 minus 1x squared, which is a 1x squared. To continue sort of our idea of simplifying algebraic expressions, it's good for us to look at what's called order of operations. Again, lots of you will be familiar with this process, but it's good for us to look at it together. So the order of operations is as follows. We go through them in steps 1, 2, 3, and 4 in that order. First thing we do is to perform all operations within grouping symbols. This means within parentheses or brackets. We start with the innermost operations is the idea. Next is evaluate all exponential expressions. Next is do all multiplications and divisions in the order they occur, working left to right. What this means is if you have multiplication and or division in your expression, if you're in your algebraic expressions, perform them as you experience them when you read the expression left to right in that order. Lastly, do all additions and subtractions in the same way, the order in which they occur when you read left to right. Let's consider an example. So if we have the instruction to simplify this operation here, 9 plus 2 times 3, it's tempting to first try to add the 9 and the 2 and then multiply, but remember multiplication comes before addition in order of operations. So first we have to multiply the 2 times the 3 first. 2 times 3 is 6, we get 9 plus 6. Now we perform addition. 9 plus 6 is 15. They get, of course, more complicated here. So in this expression here, what we'd like to do is simplify. First, remember, we look for parentheses or grouping symbols. I don't have any of those, but I do have the next part, which is an exponent. I have 2 to the third. 2 to the third, remember, means 2 times 2 times 2, which is 8. So we have 8 minus 15 divided by 5 minus 6. Now we have to decide what of these operations comes next. Division comes before subtraction, so we need to perform this division here first. 15 divided by 5 is 3. And now we have a string of subtractions. Remember, we perform these as we read them left to right. So first we perform this subtraction here. We do 8 minus 3, which is 5. And now we handle the last subtraction, 5 minus 6, which is negative 1. Again, you can remember that this subtraction here, if it's difficult to remember what happens, is starting at 5. Change this to an addition. It's addition of a negative 6. That means to do what? Move 6 units to the left on your number line, which puts you at negative 1. Let's consider another example where we have some grouping symbols. We actually have two sets of grouping symbols here. We have parentheses and we have brackets. So we find the innermost grouping symbols first, and that would be this set of parentheses here on the inside. They are instructing us to perform the following difference, the subtraction of 3 and 7, or 7 from 3, I should say. So first we perform that subtraction, that difference there. 3 minus 7 is negative 4. Again, if you need to change that to an addition of an additive inverse, that's okay. Or you can think of this as start at the number 3 and subtract 7 by moving 7 to the left on the number line. That gives you a negative 4 in there. Now what we need to do is continue by noticing that we have to work inside of the brackets here. Working inside of the brackets means following the order of operations that needs to be applied to this expression inside of here. Multiplication comes before this addition, so I first multiply the 2 times the negative 4, which is, remember, positive 2 times negative 4, positive times negative is negative, 2 times 4 is 8. So now I do the addition inside of the parentheses. Negative 8 plus 6 is negative 2. Now perform the brackets, which are implying a multiplication. 5 times negative 2, opposite signs, negative answer. 5 times 2 is 10. So negative 10 is our final answer for that one. Just one more example, just to make sure we're getting it, and let's this time use an algebraic expression where we're using an x as well. This is the same kind of form as the one we just did, except for now we have an x working on the inside somewhere. So first work the innermost brackets. Can I subtract 2 from x, or is that as simplified as that's going to get? That is as simplified as it's going to get because x and 2 are not like terms. We can't combine x and 2 at all. That expression on the inside is already simplified. What we can do first is use the distributive property to perform the multiplication that is being applied right here, 5 times x minus 2. So that's the distributive property, which says 5 times x, which is 5x, 5 times minus 2, which is minus 10. And now we're ready to perform the next operations inside of the brackets. I see a subtraction and an addition. We handle them as we read left to right inside the parentheses. So 5x minus 10, those two are not like terms, so I can't combine them, which means we're stuck. So at that point, what we need to do is combine the like terms over here, which is the negative 10 plus 8. Negative 10 plus 8 gives me a negative 2, or minus 2. Well, again, 5x minus 2, those are not like terms. We can't be combining them, so we perform the multiplication by using the distributive property. 3 times 5x is 15x. 3 times minus 2 is minus 6. Okay, so what comes first when we're evaluating expressions, when we're doing the order of operations? The first thing, remember, is to look for the parentheses. Parentheses say me first. The next step is to evaluate the exponential expressions. Do any exponents next. So if you're remembering this little acronym down here, this PEMDAS thing, right? Parentheses come first, then exponents. Then the next thing is multiplication and divisions. They are technically equal in the order of operations because multiplication and division are the same. Remember, division is a multiplication. It's just a multiplication by a reciprocal. We talked about that in our last video. So that's the next part of the PEMDAS, the multiplication and division. Perform them as you read them left to right. Lastly, perform additions or subtractions, again as you experience them reading left to right. So let's just finish this video with doing one last example. Let's perform this order of operations here. No variables this time, just numbers. So I see that there's an addition, a multiply, an exponent, a divide, and a subtraction. So I know there's no parentheses to imply grouping symbols, but there would be an emphasis on grouping here that would say that I need to take this numerator and divide it by this denominator here. So that implies that we need to perform what's going on up here in the numerator first before we can handle this division, right? So first we want to handle evaluating the exponent because exponents come first, right? We're working technically in this numerator here, so there is an invisible set of parentheses that we're working inside of right now to handle the operation in the numerator first. The exponent, 3 squared, is 3 times 3, which is 9. So now I want to handle the multiplication in the numerator. 4 times 9 is 36. Now I see that I have addition, division, and subtraction. Division comes before those other two, addition or subtraction, so handle that next. 36 divided by 6 is 6. Now I handle addition and subtraction as I read them left to right. 6 plus 6 is 12. 12 minus 2 is, wait a minute, that's not right, is it? Is that right, folks? 6 plus 6 is 12. 12 minus 2 should be not videos, they're not my fault. The slides, dang it, those people that make the slides, we need to fix these slides. So 6 plus 6 should be 12. 12 minus 2 should be 10. I wonder where they're getting the negative 2 from. Maybe they thought that the 6 and the 6 canceled each other, but they don't because they're not additive inverses. Okay, so we know for sure that this should be a positive 10 down here because 6 plus 6 is 12. 12 minus 2 is 10. So change that negative 2 to a 10, and that'll be the end of our section 1.8 video.